Okay, so my name is Arjun, and I will be taking the course for this SDN orchestration. So I will be basically giving the classes for the ACI and SD-WAN, and there will be one more class. So instead of Nexus, it will be Cisco ISE. So that will be taken care by another tutor. So he will be giving you the lecture for Cisco ISE. So I will be giving the lectures for ACI and SD-WAN. Okay. So, welcome to this demo session. So basically, in this session, we'll be talking a bit about the course, how we will be proceeding, and what we will be doing. So, so, um, so basically, I have been, giving the, I have been in this field for last 10 plus years. So I have been giving in the courses on ACI and SD-WAN and other SDN orchestration classes. So the thing that we will be doing in this course will be specific to ACI, how it works, how we can incorporate that one with our data center, and how SDN works. So SD-WAN basically it looks after your WAN network. And this will be a full online instructor-led training. And this is the course that we will be running on the latest blueprint that is provided by Cisco. So we have all the updated course contents on this. So we have well-rounded professional trainers that have more than 13 plus of experience, both me and my colleague as well. So we will be giving you one-on-one mentoring for quality results. So if you need anything, then we can have Q&A session. And then we will be trying to have 100% passing score and more on this later on. And also we will be providing 24 into 7 unlimited lab access to our courses. So for example, for SD-WAN, we have a course lab that we will be providing to you, similarly for ACI as well. And also we will be giving you all the workbook materials so that you can go through them during your, during your off hours. And also, there will be a bonus section as well for VXLAN, since we will be, working on ACI, so we have to know what VXLAN is. And so there will be, so if you can go down, you can see they have different labs. So we will show you the labs later on. And then we have the blueprints here for the courses. You can see for the ACI, we have basically covering all the infrastructure related topics. Plus, we have also need to understand how ACI, works, how the control plane works, how the data plane works. And then also we have how we can work with the L3 outs and L2 outs so that it can interact with the outside network. How we can integrate the ACI network with other third-party vendors, like, if we have a firewall, how we can integrate that. Plus, if we have some VMware, how we can bring the VMware network into ACI. So all those things we can look into. Plus, general ACI management, how we can, configure SNMPs and all those things, triple E. How we can do upgrade of the ACI network of the leaf and the spine switches to the APIC controller. And also we will look at the multi-port and multi-site design, how we can, bring two different networks from two different sites that are in two different geographical locations, right? So that will come under multi-site. And multi-port is basically when you have two different networks that you need to bring in within, within a radius of 50 kilometers, not more than that. So basically, we need to make sure that whenever we are planning to have any multi-port design, we don't go beyond 50 ms. So that is the threshold. And then we have some courses on the SD-WAN. So here is the SD-WAN blueprint. So here we can see the architecture, the topics that we will be covering on management plane, the control plane, data planes, orchestration planes. What is the difference between legacy network and SD-WAN, how it helps us in our day-to-day life, how it makes us as a network engineer, how it makes easier to control multiple sites from a single plane of dashboard. And what are TLOCs? Some of the vocabularies that we will be using in SD-WAN, like TLOCs. Then there will be a VPN. So VPN is is similar to the tunnels that we use, but it's more kind of a VRF that we use in our legacy network, but in SD-WAN we call them as VPN. Then how we can use SD-WAN platforms on different networks, like if you wanted to onboard them on the cloud, on AWS or Azure, how we can do that. So all those things will be explained here, and we'll be doing some practicals as well on those. Then how we can set up our controllers like the vManage, vBond, vSmart, all those things. How we can bootstrap them, how we can configure them using certificates. All those things we'll be working on. Also, we'll be working on templates, like how we can design a specific WAN network, like hub and spoke, spoke to spoke, full mesh, all those things. We can configure them using templates, plus how we can manipulate the traffic to go out via the data center instead of local ISP, and plus also the reverse method, that how we can prefer the local ISP than to go out via the MPLS part, so that all those things can be configured using templates in SD-WAN, and it makes us and it makes the network engineers, from a configuration perspective, it makes very easier to deploy them. In a legacy network, when we used to work on multiple sites with hundreds of routers, it makes us very tedious to work on hundreds of devices at the same time so that we can build a specific network. But here in SD-WAN, you can just click, deploy the template, and the whole network will be designed for you. So
So,
we can,
Arjun, just question. So, when we're talking about those labs and doing these things in the practical, so are we going to start from the scratch, or like how it is going to be like deploying router or the lab? I just need to see the demo, like how means once we are done and covered this particular part, right? What all in we are going to present today. So, how we are going to start with the lab? Is it just needs some information over there?
sure. So I will go to the lab section and I will show you that. So I will
All right.
first complete just overview of this one, then I will go through one.
Mm. Okay, thank you.
And then we have the policies here, the same thing that I was talking earlier, how we can configure control policies, data play policies to restrict traffic between one site to another, how we can create topologies using templates, QoS materials. Normally, it uses so much time to configure QoS, right, on a WAN circuit. So here we can just deploy them as a template, and they will work. Plus, we can look at the management section as well. So this is the VXLAN that I was talking about earlier. So we have the VXLAN basics. So we also will cover some of the intermediate VXLAN topics, how the VXLAN works, what is the packet walk, what are the different methods that uses to learn the endpoints. So MPBGP, we will also cover that one, so that BGP EVPN will also be covered in the VXLAN topic. And some of the advanced topics like how we can configure BGP EVPN to carry the VXLAN traffic, how VXLAN will be used in ACI, which will also be covered in the ACI course. So this is a general overview that we will be covering. And there will be one more section in the same bundle, which is the ICE. It is not particularly shown up here, but it is it is there on which can be put up by our colleague later on. And when we are talking about labs, so we have different lab sections. So let me just show you one of them. Okay. Okay, I think the lab is getting stuck, so it is not particularly working right now. I think I have to just because it is ideal for some time, so I think it has been timed out. So I will get back to that later. Okay. So let me see. So okay, let me look into that later on. So I will just go through some of the demo, one of the demo section. So I will be taking care. So first, uh, so do you, just trying to understand. So because when we will start, so first we will start with the SD-WAN course actually. So we will first start with the SD-WAN and then we'll later move on to ACI. Okay. So I hope everyone has got some level of networking knowledge who have joined here because uh, we will need at least a basic level of networking to understand how how the SD-WAN, how basic network works, right? So once we have clear visibility on that one, it will be much easier for you to basically understand and grab it. So give me one moment. I will just open up one section like this. Like this. Thank you. I will open up my board. So let me know if you guys see that. Okay. So it will be a black screen. Do you see my screen?
It is,
Or
yeah.
whatever I'm typing. Okay. So I will, whenever I will be starting any courses of, when I will work on the particular class, so I want to make them interactive. So that I will be asking questions to you and, so that I understand that you have got what I'm teaching. Okay? So, just for this demo session, I will just start with the first chapter. So, let's see. Okay. So the first chapter is basically we need to understand what SD-WAN is. Okay. So what are the benefits of SD-WAN? So before understanding the benefits of SD-WAN, let's start with the traditional network, which we are basically using every day. So what are the traditional benefits that we have? So this section will breaks down why traditional WAN architecture become unsustainable at large scale, and how complexity, arises in enterprise environment, right? So suppose you have a small network. It's fine. When you have a small network with two sites, then it is easy to manage. Like traditional WANs are fine in this section. However, the problem that SD-WAN solves are more visible in large-scale enterprise networks. For example, you have 200 sites, 400 sites. Now you are managing around 400 separate devices. Right? If you need to configure a particular design, then you have to consider around 100 of separate devices that you need to configure on. Right? So to ensure reliability, sites often use dual bounds. So that means if you have 100 of sites, then you are managing around 200 devices. Then you will have each devices will be connected to ISP service providers. And suppose you have two service providers, one is for the primary one, other is for backup. Now this doubles the circuits and the connection that you have to monitor, right? So, and along with that, right? For example, I have a site here, site one. I have one more site here, site two. Now, in site one and two, you have one, two routers, and similarly, you have here as well one, two routers. And then suppose you have one ISP here, right? Disconnect to this one, and then you have one ISP here, just connected to this one, like this, like this. So now you have already got, just looking at this, you have already got a little bit of complexity. Imagine you have hundred of sites like this, right? Over on top of that, you have different media diversities as well, right? That you need to tackle on. So for example, you might have some T1 and E1 links, like for low band. And for modern, internet handoffs, you have fiber connections. And then you might have, for the backups, you might have some cellular cellular backups like 4G and 5Gs. And also on top of that, you might have other VPN tunnels as well. Okay? So since bandwidth varies widely, so we as an engineer must manually understand like uh, each and every circuits have different bandwidth capacities, right? So in order to guarantee bandwidths for critical application, on top of that, we need to have QoS as well, right? Now, managing these policies across hundred of devices with different link speed is tedious, and it will be error prone because you are not the only engineer who will be working or designing this network. You will be working as a team. Today, you might be working. Tomorrow, someone else will come and change and will configure something, right? So it might not follow a particular standard, right? So that is why SD-WAN can solve most of these things, right? For example, if you are on top of, this is fine. Along with this, you might have different routing complexities as well, right? For example, obviously you will be having some BGP peering between them, right? And now, if you have BGP peering between two ISPs, so obviously you will be working on different, mm, for example, you will be doing some traffic engineering on them. Maybe you will be uh, preferring this link over this one. Like you might have a primary one and the backup one. You might have some local preferences created or MAD values created, ADs, lots of things that you can work on to make one primary and the secondary. Right? And also when you're working on some metro Ethernet, suppose this is a metro Ethernet between them. This might not have this. I mean, these routers are basically for the same site, but they are not maybe not on the same building. They might be 1 or 2 kilometers away on two different complexes. So we'll be needing here a metro Ethernet between them, right? So you can just imagine just you know when I'm talking for last 5 minutes, I have put down so many things that can make a network WAN network so complex, right? And on top of that, we now have cloud as well. We have AWS, Azure, and lots of our servers or applications are running from here. So we have hybrid data centers. Sometimes we have data centers that build up on cloud itself. Small enterprise networks are directly built up on the AWS. And also we have networks where people are building hybrid data centers where some of our servers are on our physical data center and some of them are on the cloud, right? So maybe users at the branch offices need to access some of the cloud applications that are located here, right? This site, now just imagine this is your HQ here, and the HQ is connected to the AWS via this particular ISPs. Now, you as an engineer or as a user here, if you need to access one of this AWS application that is hosted here, you have to go through the MPLS link, reach your HQ, where our main internet connectivity is. And from here, it goes out to the AWS. Imagine you are in India sitting here, but the HQ is in maybe in US. Then you have to go around the earth just to reach this AWS application, which could have more, smaller latency path via the internet connection directly, because they have AWS a presence everywhere. Right? They have different regions where they could have their servers, uh, where they have their servers created. So, in order for such networks to work in this particular design, SD-WAN shines on this, right? You could have different templates created to make sure that instead of taking this long path via the data center, I mean your HQ data center, you could have used the smaller or the easier or the less latency path directly via the internet. So all these things will uh, make your life easy, basically, right? Now, how SD-WAN solves? Now I have defined all the complexities that brings up by the legacy or the traditional uh, networking for the web, right? Now, SD-WAN as the magic one for all the specific issues, it will solve them one by one. So let's see. So how SD-WAN will solve this? So for example, the first one, the apps, the complexity that the WAN traditional one brought. For this one, it will treat SD-WAN will treat all the transport types like MPLS, BGP, MPLS, the cellular 4G or the broadband as a single pool of bandwidth, right? So it will makes easier for you to choose one application to go over a path which have more latency and jitter directly, and that will all be calculated by the controllers so that they can make a better path to the destination. You don't have to worry about that. And all this is possible because they have what it calls an application awareness. Um, application awareness. Now, what is application awareness that SD-WAN brings? It intelligently routes traffic based on the application need. For example, if you are using some kind of, for example, Joon traffic, right? So it will make sure that the Joon traffic takes the fastest link automatically. You don't have to configure them every time, right? So that will done automatically based on the calculations that will be done by SD-WAN. He will look at maybe it will use the 5 tuple match. He will see what applications are coming in. And based on that, he will choose the best path that can send the traffic out of that particular site. Even though it's primary and secondary, it doesn't matter for him. In SD-WAN, basically all the ISP sites are using as an active-active solution. It will choose whatever is the best one, and it will, and will send the traffic out along with that. Now, base and later on we will have some more detailed explanation on all this thing. And the third thing that we will SD-WAN brings in is the centralized management. And earlier when I was talking about 400 different types of devices that you have to manage one by one, but what centralized management will do, it will basically give you a single pane of window where you will configure the network once centrally rather than touching all those 400 individual routers one by one. Create a template, you make it ready once, and you have, well, basically you make a template and make it ready for the edge routers. So that once the edge routers comes online, they will automatically get those configurations and start sending traffic. You don't even have to, configure the routers by yourself. And that is what we call a zero touch provision. Right? So all those we will be seeing in this class. And, and lots of other benefits that SD-WAN brings in, like the routing. Other thing that I was talking about was the routing complexity, right? The routing complexity is vastly solved by SD-WAN here. The traditional WAN requires complex BGP peering, manual traffic engineering like ADs, metric calculations, all those things across hundreds of routers. Those are easily solved by SD-WAN, like I was talking earlier. It will choose the path automatically based on three things. It will choose the bandwidth, jitter, and latency. So they will basically create this record for this particular link every a few minutes, like for example, every 10 minutes. Okay, you can change this value depending upon how frequently you want to measure the uplink, but it will create it will have a record of this one. And it will then take an average of this and it will understand which is the best path to take the traffic out of that site. You don't have to create all those complex configurations like uh, um, like um, maybe you have some kind of route maps created just to make sure that you are matching some application traffic and sending out over that one, creating IPS list by yourself. You don't have to do anything like that. Give me one. Okay, the second thing, okay, the fifth thing that we have solved here is the cost. Because earlier I was talking about the benefits of having an MPLS path, right? Now, MPLS path is good, or you can say it's the best one that we have right now, but it's costly. Okay? It's very costly to maintain the MPLS path. But in respect to MPLS, internet connection is very affordable, you can say, right? And also nowadays, internet connectivity is very stable. If you can say if MPLS is 99% up, an internet connection, good ISPs can give around 98% of SL, right? So you can use both of them in two different scenarios. Like you can use the MPLS path to have our reliable traffic out of here, like the voice traffic, right? And we can have the internet circuit for other less reliable things like backup or some specific data traffics that you wanted, that you don't want to have too much of reliability. So all these things we can basically SD-WAN can uh, you know it can give you the benefit of choosing or it gives you the benefit of having two different type of networks in a site. So that instead of having two MPLS circuit, which will cost you more than to have one MPLS and one internet circuit, so that you can utilize both of them as per your need. Right? And some of the, and also it gives you one more benefit if you have an internet circuit locally, that you can just have you can have this internet circuit to break out you can use this internet circuit to send your traffic directly out to your AWS network locally from this site instead of sending it out to your headquarters, then to your data center, which could, incorporate more latency because it is going to your data center and then to the cloud instead of having the cloud connection directly from your internet circuit, which will give you smaller path and also less latency. Right? So, and since we are using a centralized management, you will also be having a good monitoring screen for that one. So normally when we talk about monitoring, we have to rely more on some kind of monitoring tool when we are managing that large section of devices, like 200 to 300 devices. When you are managing them, you need to have some kind of monitoring tool to see their health, uplink health, is the ISP is working fine, if there are any kind of errors on the link, the utilization on the link. Right? But here, SD-WAN, since it is, since we are managing all the routers centrally, it also gives us a full view of our network just from the vManage. We could see how the routers are working. If there is some kind of error, it will just give you the result directly on the dashboard. If there is some routers which are down, it can just show you directly on the dashboard that these routers are down, and we can appropriately take the actions on that to resolve it. Right? Uh, so the core. So now here we have understood how SD-WAN brings, what SD-WAN basically brings us in our plate. We have seen how it solves lots of our issues or lots of the complexities that a uh, traditional networking brings in regards to WAN routing. Right? So now there are some core architecture and features that we need to understand where we will start working on uh, when we'll start working on this particular technology. Right? So let me just open up one more page.
So when we are talking about this centralized management and we were talking about this monitoring stuff, so
Mhm.
do we need to purchase additional licenses for that, or is it like included in this SD-WAN part to have this type of monitoring, whether the device is down or there is any latency
So
on that particular link?
now those, if you were talking about normal monitoring, so they comes by, they comes by default with your normal routers. And so, for example, when you buy a particular router or an edge device, so they comes bundled with all those licenses. But in I know if you need more licenses, like for example, there will be a section for insights and analytics. For that, if you need to go more deep dive into having, for example, you wanted to run some kind of net flow, you
Yeah,
wanted to
NetFlow, top
monitor,
blockers, right?
right?
Mm, mm,
For those, you need to have a insight license or analytics license that you need to buy separate.
mm. So in short, like we will be only getting the normal node status and the utilization
Ah,
part. That's it, right? Nothing
yes,
above that.
yes,
We
nothing
still
on that one.
and
Yeah.
we
So
still
if
need
you
the other monitoring system like solar winds, etc. will be needed, right?
Yes, for all those things, if you wanted to do some, if you already have SolarWind, then you can send a net flow traffics to them. They
Mm-hmm.
will, they will do the
Mm-hmm.
same thing. But
Understood.
if you
Understood.
wanted to get more details like costing and all those things, then you need to have a separate license for them, for which is part of the analytics for the SD.
Mm-hmm. All right.
Okay. So, and I will just go through the architecture part so that you guys understand, and also the feature as well. Okay, give me one moment. Okay, so in this section, or we will understand how SD-WAN addresses all our problems, like the architectural changes that we are talking about earlier. Now, we will go through some of the core architecture features, like for example, and also some of the vocabularies that we will be using in SD-WAN, so that it becomes easier for everyone to understand when we'll go through this course. So we have something what we call as OMP. OMP is basically the full form of OMP is overlay management protocol. Now you can say OMP is kind of I mean, this is a protocol which not only sends routing information but other policy informations as well. It can exchange routes. It can exchange keys, the security keys, and also it can exchange our policy informations, like the templates and all this stuff, the control policies, the data policies, all this stuff. So, so these are, uh, I mean, this is a basic thing that we have to work on later on, which will give us more idea on how to, how this OMP works, like how OMP can be used on the policies to change routes and everything. Okay, how it can be used to create the VPN networks. So earlier, I was talking about application-aware routing policies, right? How it can use, earlier I was talking about basically application-aware. Now, application-aware that brings the SD-WAN can be incorporated in our routing policies as well. Like you configure this to ensure that voice traffic takes the path with the base metric, right? So, um, for example, there are two circuits. If one circuit is having a better path based on the loss and latency and jitter, it will take that. That's it. Okay. So these are the three things that it calculates by itself. And this is all because of the application aware, you can say, route policy that we can use directly on the edge routers. Or these are the policies that we basically push to the edge routers so that it can make the decision. Right? And then later on, we will be doing something based on APIs as well. So we will see how we can use the API to get the data more from our routers without even having to log on to the controllers. Right? For large scale management, you can interact with the vManage controller program and just like creating some kind of Python scripts. You can directly use those uh, you can use those API interfaces to directly interact with. And this is beneficial for pulling the reports on the link quality. And also based on the link quality, you can automate most of the thing and automate policy out. For example, you have different policies. So you can use policy, you can, automate the policy updates based on the link quality that you can pull from the API controllers, right? Also from the vManage controller via the REST API. Now, you might have seen or might have heard about SD-WAN planes, right? So this is one of the fundamental things in SD-WAN. Uh, Now, let me talk about some a little history of the SD-WAN. Okay. So originally, Cisco had a product called iWAN, or what it called as intelligent WAN, right? So, but it fell behind the competitors. And to rectify this, Cisco, what it does, it acquired a company called Viptela. Right? So Cisco used the Viptela name, but the product line is now officially called as Cisco SD-WAN. In initial days, you might have heard about Viptela when Cisco was first starting this line of technology, but later on they are rebranding everything as Cisco SD-WAN. So now, so this is just a general overview of how Cisco basically came up with SD-WAN. They didn't create it by themselves, but they just took it from it. Okay. Um, so even though the Viptela name is gone, we can still see the Viptela thing everywhere. Like for example, the vManage. When we say vManage, it is not virtual management. It is V for stands for Viptela. Okay, like vManage, vSmart, all those things are V stands for Viptela. Now, when there are the four planes that they have, I mean, SD-WAN basically have four planes. Okay, so one is what we call as the control plane. The other is what we call as the data plane. And then we have the uh, what is it? Management plane. And then we have the orchestration. Okay. Hmm. So I will just go through them. I mean, I will not go in deep. I will just go through briefly. I will go through them briefly. And then I will try to open the lab again so that I can show you. Okay. Sorry. Give me one. Now, in a normal traditional traditional network, like for example, the routers that we are using, the Cisco IS routers, the control plane and data plane, management plane, orchestration plane is little new in the network. But these three things are present in our normal routers as well. Okay. Like in our normal router, we have this three plane built in directly in the device. For example, this is the management plane where we use our, uh, you know, where we, for example, you put the console in, you take the access of this device. Also, maybe you have a virtual terminal connected through one of the laptop. So any connection that you are making to this device to take control of it is our management plane, right? Now, there is the control plane, which is also in this device. Control plane is basically which is used by the device to make the routing decisions. If you are running some kind of route map, also that will be used by the control plane so that each and every traffic that comes in, if it matches the rule, will send to the control plane, look up by the route map, and then send it out again to one of the IO ports. Now, this is the break, right? Which is basically being used by the device to uh, take control of the traffic. Below that, we have the data plane, which is also in the same device. Now, this data plane is just sending the traffic in and out of the switches based on the ASICs that are created on this interfaces. Right? Well, the one of the traffic comes in one of the interface, then it gets sent. If it matches the policy, it can send out to the control plane, look up by the policy, and then send it out via the other port, and it goes up. If it doesn't matches anything, and if it already have in the forwarding table, then it will just send it via the data plane and goes out by the other port. The data plane, we have the control plane, we have the management plane. All these three things are on the same device. In SD-WAN, all these things are broken. They are not on the same device itself, right? So, for example, we have the vManage, we have the vSmart, then we have the vEdges. All these three separate devices. In this case, in our SD-WAN case, the vManage will become the management plane, right? vSmart is basically the control plane. The vEdge will be our data plane. Okay. Now, what is the benefit of having a decentralized, uh, you know, architecture like this for the device itself? One of the benefit that it brings is like you have a single management plane now. From here, you can control multiple edge devices. You don't have to log into each and every device, create a, to create a policy or to create a configuration. Right? You do it here, and it will be sent out directly via the vSmart to each and every nodes. If for some reason the management plane goes out or the vSmart goes down, then your data plane will still work and run for next 24 hours. That is the default. You can change it, but it is the default. So it will still run, right? It will still forwarding traffic. It will not going to take any new policies that you want to deploy, but with the existing configuration that they have, they will still forward the traffic. Right? The ways once they comes online, then they can take the control again. But in this case, if your management plane goes out, then you don't have the access to these devices anymore. And this device is just, mm, it is just there on the network and you cannot manage it from anywhere. If the control plane goes out, then this device is dead, right? So you can see that having a decentralized uh, device gives us lots of flexibility, right? So let me see if I can bring up the lab once more.
So I think if we lose the control plane access, so what all the current templates we have for on the vEdge, that will not have any
Mhm.
impact. Only the new templates we will not be able to push, right?
Right.
Is there any like flush out time? Something is there in vSmart
20,
or
and they, no, I mean, these devices uh, can stay without the reachability of the vManage vSmart for 24 hours.
so after 24 hours?
They will become, inaccessible because basically what they do in every 24 hours, they will start trying to poll and see if they have still reachability to the vManage. If they don't have the reachability, they will basically, loses its configuration.
Mm, okay.
So let me see. Give me one. Let me try once again to check the lab. Okay. Okay. Can you see the topology here?
Yeah, it is visible.
Yes, yes.
Okay. Okay. So we will be using you know, we will be using a similar kind of topology here that you are seeing. So the basic idea of the whole course, and which will have all the design perspective here that we are showing. So we have a site, right? We have a HQ here where we have the vManage, vBond, vSmart all configured in the HQ. Then we have different sites. Like you can say these are the branch offices. We have a beta site here. We have alpha site, zeta, gamma sites. So these sites are basically connected to this HQ using some form of ISV, maybe internet and MPLS. And this is one of the backup you can say. Right? So we have a CS server here. So this CS server is needed because we have to work on the licenses and certificates that needs to be used by the vSmart, either by the vManage, vSmart, and vBond to have proper authentication. Plus, this license service will be used to send licenses to the edge devices so that they can, once they come in, based on the licenses, that they can automatically get registered to the vManages using the vBond. So vBond is kind of I think I haven't told you earlier, but the port plane that we had earlier, what we were discussing earlier, the port plane that I was talking, it is called the orchestration plane, uh, is basically for the vBond. Okay, so what the vBond do is like uh, it helps to onboard all the devices. That is the only thing that vBond do. Once the onboarding is done, you can basically, I mean, the devices will automatically, will delete the connections that they will make with the people. Okay, we will show, in more details on that part later on, because each and every topic will take time. So I will, once we go through each and every topic, then we can have more deep dive concept on.
So
So,
Arjun, so
yes,
zero touch provisioning will be done by the vBond only.
right.
Okay. So what about like initial configuration, the management IP
Yeah,
reachability? We need to
that
do
we will
that
do.
or
Uh,
that?
in an enterprise network, that actually can be pushed automatically from your DHCP server, maybe. But here we have to do it manually in our lab. So we will
Okay.
first
So
bootstrap. We will bootstrap
yeah.
the routers, and then they
Okay.
can onboard automatically.
Okay. So
Okay,
only
but
I need to connect the uplinks,
ah,
any management IPs.
yes. Okay. Uh,
So only we need to connect the fiber connectivity or like any LAN connectivity. Once it is connected, vBond will push all the configuration, including the IP address.
yes.
Okay.
Okay. Okay. Okay. So we will go into those later on when we'll see how we can bootstrap the devices. It will be easier. Now, based on the time constraint that we have, so what I will do, I will just go through the lecture quickly, and if you have any questions regarding the section, you can park those questions. I will have a Q&A session with everyone, so that once this finishes up, then I can answer them one by one. Okay. Okay. So this
So
is our.
Arjun, one
Mhm.
more thing,
Yeah.
like about the connectivities, ISP links, like 4G, 5G, MPLS, internets. So how it segregates, like how it is managing all those links and providing the high availability.
Uh, I didn't get your questions actually.
So we can have the like multiple links, like
Uh-huh.
T1 even link, T1 in that is for the connectivity, the MPLS link, internet
Mm-hmm.
link, 4G or 5G connectivity
Mm-hmm.
in one side. Like in one side, let us consider two ISP links. One is 4G,
Mm-hmm.
another one is like MPLS link. So in terms of the high availability, how the SD-WAN is managing both links?
We'll
Like
have
in
both the
case
links
4G
actually.
goes down, yeah, in case
Mm-hmm.
4G goes down, so how my traffic will be flowing?
And if you force a link, if any of the link goes down, it will always have the it will always have the other circuit used to reach the destination. You will see that later on, because later on when we'll be working on that, when I was talking about VPN, they will have something called a TLOC section. Okay, the transport locator. So those transport locator which basically carry the information of the circuit itself. So they will know which destination, in order to reach what destination, what ISP links are available and connected to them. In normal routing in legacy network, this device, this router might not know what this particular what this what this router is using. What ISPs are being used by this router. But in SD-WAN, this device will know that in order to reach maybe this network or maybe this network, which ISP circuit it can use, and which one will be more, more, you can say, error prone or have less latency to reach this destination. Okay, it can create the whole WAN map by just with the help of this TLOC and the other OMP protocols that we will use. You can imagine, like OSPF, right? In OSPF, what we have, it's
Yes.
a link state. It's called a link state, right? So each and
Yes.
every routers knows their links, how to reach a particular destination. Like they can create a map by itself to reach a particular destination.
Okay.
Same concept you can understand in the WAN. If we bring that same concept in WAN, how it will look, you can just imagine the same thing. For example, each and every router in the network knows what they are connected to and which circuit they can use to reach a particular destination. If one circuit goes down, he will know that in order to reach that particular destination, if he have a similar or less reliable circuit to reach. If it doesn't, then it will just drop it on the edge itself.
Like automatic failover, correct?
Or yeah, automatic. Everything is automatic in SD-WAN.
So what about like link load balancing?
That will be done using application error that I was talking earlier. So they will use different topology. They will use different application error values for each and every traffic, and they will understand the traffic based on what application you are using, and they will choose which circuit is best for that particular traffic. And all those can be controlled by the policies that we will create in the vManage.
Okay, so it also supports the like multi-cloud setup.
Yes, we can deploy
Okay.
directly our edges, virtual edges. You can say the CS routers, the CSRs. You can use the
So do
CSRs
we
and you
need
can
like
directly
physical
deploy them.
routers or virtual routers are
Anything can
okay?
work.
Anything
Anything.
can work. Okay. So
Yes.
any special
The V
requirement in
edges,
terms of the certificates,
right,
licenses?
right. So I will show that later on. So when you will use the virtual devices, how you can onboard them directly on the vManage using the whitelist that we can create. And
Okay.
all these things we will see. Okay. And the V edges that we have, they can be virtual or physical. It doesn't matter. vBond, vManages, these are all virtual devices. Okay. So this can be virtual or physical. And in the real world scenario, I'm talking about same thing. The vManage, vBonds, these are all virtual appliances. They don't have physical integration. I have vSmart as well. So,
Okay.
okay. So now this, no problem. So this is the topology that we will be using. A similar kind, but you can say uh, a less complex, with a less complexity so that we can understand better. Okay. But I will use the uh, same kind of topology with less connections so that it becomes easier to understand how it is working. Okay. Uh, okay. So Sam, you can see one of the site here has got two TLOCs connected. Two devices connected to each other. So now this gives us the opportunity of what we call as a TLOC extender. So we can basically use both the ISPs, through the routers. For example, if this circuit goes down, then this this router can send the traffic over this ISP using this particular link that they're connected between each other. So how we can create those TLOC extenders, we can see that as well. Let me see if I can open the vManage. 1 minute. Okay. And later on, I will show the bootstrapping and everything. But if I can just show you the initial web page of the vManage, let me see. It works. It might have hanged. The PC might have hanged, so it's fine. So I will just show you something here. So when I was talking about earlier about the bootstrap configuration, so I will just give you a sneak peek of that one. So you can see when we first start vManage, it will basically start with the default login credentials. Like the default one will be admin and admin. So username admin and password is also admin. So once you type that, you can they will ask you to set an initial admin password. For simplicity, I will just put admin. Okay, you can put anything. Now then, it will ask you if you wanted to use the vManage for compute and data both, or only you wanted to just control the devices and not data. So I will say that I will use for both compute and data. And yes,
Sorry to
and then it
interrupt
will
you.
just use.
Can you please make little bit bigger that CLI? So not able to
Uh,
config spot.
okay, okay. Let me see. Wait a minute. Is there an option to
Yeah, I think you can drag and drop something.
I can uh where is that option? I'm trying this fine. Okay, let me see. Hmm. No, I think they wanted to make the font a little bigger. That will not work.
You can use the Windows Zoom.
Where is it?
There is a Zoom in the Windows. You can use it.
No.
Yeah,
See.
you can proceed, I think.
Okay, let me try one
Or
sec.
for now, you can use HTML console.
Okay, I will have to see how it can be done, but I can look into that option later on. If you can just bear it for today, I will see that option. But is it still, I mean, readable, right? Or it's not even readable?
Yeah, I think it is good. You can go ahead.
Okay. Okay, so for the storage, I will just use the available one that I have. So it's just the 100 gig for the virtual database. So this is zero anyway. I will just click one and type enter. I will say format. It will ask you to format. So every time I would say yes. Now, based on this, it will take around around 4 to 5 minutes. And We just have to wait. So basically, it will format the drive and will install the uh, install the image on of the vManage on this one. Okay, so let's give some time, and it will work. And till the time it boots up, I will just show the. Let's start with the vBond. Okay, I will show the vBond. So just by typing here, you can see it shows that this is a vEdge, right? So vBonds are using the same image as the vEdges. The vBond is not a different device, so you can use any of the vEdges and make it a vBond. I mean, you cannot just use one of the existing vEdges and make it a vBond. But what I'm saying is like, if you wanted to deploy a vBond, then you can use the same image of a vEdge. It will work. The default, same, admin and admin. Now, okay, now it is booting the kernel of the vManage. Let it cook. So in the meantime, here I will just set the same thing, admin and admin. So now it will just give us the prompt of vEdge. Now, we will do, I will just show you the bootstrap configuration for the vEdge. Okay. So, sorry, not the vEdge, vBond. This will be same for both the vManage and the vSmart. Only a small slight items will change. I will tell you here as well what will change this. So first we'll go inside the config mode. I will just say config and press enter. We'll come into the config mode. Now here I will go into the system config. I will just say system, type enter, and I will be in the system mode. Here I have the option to give the host name of this device. I will just say that this is a vBond and press enter. You can say that immediately it doesn't change it. Like our normal devices, when we say host name and give the new name, instantly change the name. Here, the concept is a little different. Here we have to commit. Every time we do a configuration, we have to commit. And once commit, you will see the changes. Okay, everything right now is in the you can say it's similar to a candidate configuration. Okay, it is not a running configuration. Now we'll say hostname vBond, and we have to give it a system IP. So it is similar to what we call the router ID. So I will just give a system IP. This is non-routable. This is just a name, or you can say a distinct IP for this device to be recognized in the topology by the other devices, just like router ID. Okay. I will just give it a system IP of maybe 777.106 or something like that. Anything you can give. Private, public,
So,
doesn't matter.
excuse me, Arun.
Yes.
So, this is a type of management IP?
No. This is just a router. You can say just a distinguishable name that you are giving to this device, so that it becomes, distinguished when you are showing up in your neighbors, or when you are looking up at your device list later on. You will show up as the devices will show up with this IP address rather than your management IP addresses, so that you know what this device is.
So, this is a type of host name.
Yes, you can say. You can say it is more comparable to a router ID, if you know about router IDs.
Thank you.
Like normal legacy networking, when we used to do, dynamic routing, we provide router IDs, right? Between two devices. So that when you do show IP, I mean, when you do show neighbors for any routing protocol, instead of the connected IP addresses that is being used to exchange route, it will show up the router IDs. Right? Similar kind of thing, the system IP is same as a router ID. So when you see the neighborship, instead of the linked IPs, you will see the system IP addresses for a more distinguished understanding, or like what this device is.
So it's
When you will
like a
proceed
loopback
for
IP address?
not exactly, loopbacks are routable, right? So these are not
Yes.
loopback IPs. So these are non-routable IPs. Just to, you can say this is a name, a distinguished name that you are giving to this device,
Okay.
so that it can be easily recognized when you do, or when you will look up in your list. Okay, so now the other important thing is like the site ID. So we have to make sure that all the devices that you are configuring need to be on the same site ID. Otherwise, they will not be showing up in your so-called neighbor list. They will not be able to recognize themselves. So some of the parameters that needs to match is one of the site ID. Site ID needs to match on each and every devices. The other thing that you need to match is what we call as the organization name. I will just put here maybe network. Okay. So this organization name will also have to match on each and every devices. Okay. The other next thing that we have to configure is the vBond IP. So till now I haven't configured. Okay, so now I'm configuring the vBond itself. So I will give a vBond IP. Even though this is a vBond IP, even though this is a vBond device, I still have to tell him that you are the vBond. Okay, how I will do this? I will just type in vBond. I will give it a name, give it an IP, maybe 10.10.1.100. And then I will say you are local. So this local keyword defines that this device is the vBond itself. Okay. So now I will exit from this system configuration. Now the next thing I will configure is the VPN 0. I haven't gone to the VPN concept till now, but as a demo class, this parts actually comes later on, all those bootstraps and everything. There are a couple of more theoretical sections are there where I will discuss about the VPNs, TLOCs, OMPs, all those things. So since I'm skipping all those right now, so I'll just tell you that VPN is 0 is basically for the we can say this is the transport layer. Okay, so VPN 0, this is the default one. You can say this is the default transport VPN. So I will just type in one of the interfaces that are being used by that I can associate actually to VPN 0. So here is the vBond. vBond is using gig 0/1 and 0/0. Now, this right-hand side will be the one that I will use for VPN 0, which will be our transport network. And this one will be our management, okay, which will be VPN 512. These two are default. Okay, it is not that I'm making up myself, but these are default that are being used by SD-WAN, VPN 0 and VPN 512. Now, VPN 0 is for transport. This VPN 0 or the interface that I'm going to assign to VPN 0 and the IP addresses that are assigned to VPN 0 will be used by the devices for making the connection up between the devices. For example, the VPN 0 will be used to bring all the device neighborship. Okay, VPN 512 is basically purely for management purpose. It doesn't come under the main transport network. Now, in VPN 0, I will assign one of the interface. So right-hand side, I will be used for VPN 0 for the transport network. Now here you can see it is using gig Ethernet 0/0. I will gig Ethernet 0/0. And then I will just type in the IP address. IP address maybe 10.10.1.100. Since this is the vBond that I'm configuring here, so it has to have the same IP addresses because this is the vBond itself that I'm configuring. So in this way, I can give the subnet /24. I will say the command no shut so that it comes up. And yeah, so this is for the VPN 0 configuration. Okay, I will exit this section. I will exit one more time. And then next I will go into the VPN 512, which is for the management. Now here I will again call the interface or associate the interface. Here I will say I will use gig 0/1, gig 0/1. I can enter. And then I will give the interface IP address, maybe 192.160. This is a complete different network, right? So I will give it totally different network, maybe 1.100 again, /24. And do no shut, exit. Now, I'm sorry. Now I have to commit this. Commit, and you can commit and then quit, but I will just say commit and quit. And then it will just commit it, and it will come out from the config mode directly into the manual mode. Now, if you see the running configuration of this one, you will see that I have given the system hostname, vBond, system IP of this one, site ID, this one,
So
vBond IP I'm saying.
So Arjun, all interfaces will have the /24 address.
No, I mean, this is just an example. Later on, when I will create the topology, I will define what network I will be using on which
Like
section.
what about
So that
like /30, 29?
and no, I mean that will be more point to point. So for example, just look here. Let me show you. So in this here, if you can see this network that I'm using, this will be a LAN section, right? Sorry. This section that I'm using here is for the connectivity between the vBond, vManage, and vSmart. I won't be using point-to-point connection here. This will have to be in the same network, all the three devices on these three interfaces. Right? What I will do basically, I will use this switch as a layer 2 switch. I will just create access VLAN on them, and I will be running maybe 10.10.1.0/24 network on this. Okay, maybe I will use VLAN 10. Okay, I will use VLAN 10. I will connect all these three interfaces on these switch interfaces and make them part of the same broadcast network. So that
Got it.
if they need to,
so vManage, vBond, and vSmart all will have in the same VLAN subnet.
Right. So that they can have, they can have the connectivity without inversion, and they will have on the same network. Similarly, on this side, what I will do, I will use a similar network. Maybe I will use this 192 section that I was talking earlier, 192.1.0/24, so that I can use this. So for example, if I will give this vManage IP 192.168.1.107, I can use this IP address to access this vManage using GUI. Right? So this management IP addresses will only be used to take manage of these devices. And this side, this this network will only be used for the to building the network. For example, to build the neighborship between them, to send to send information from vBond to vManage, vManage to vSmart. All this will be done using this particular LAN segment. Okay, and later on, what I will do, I will just make this router here. I will make this router as the gateway. I will give it an IP 10.10.1. maybe 1. So that in order for this vManage to reach all these devices on the right hand side, all these edges, they can just use this gateway to reach them. Okay. Similarly, for the vSmart, if they wanted to reach the devices, it will use this gateway. Okay. I lost it. It is the vManage. Okay. Let's see if it comes up. But let me complete the vBond first. So yeah, so so this is the vBond IP, the system IP, site ID. Then I have the vBond IP here mentioned and telling him that this is the local, that you are the vBond. The organization name, I would say that this is this. I mean, this is basically you can say like domain that needs to match on each and every devices so that they can be part of the same, same certificate. Later on, we will be using the same organization name on the certificates as well to distinguish and to have trust. And then,
so Arjun, this system IP addresses will not be reachable from outside.
No.
Okay.
They will just for display. Okay. So then we have the username and password, and if you come down a little bit more, then you will see the VPN 0 configuration that we did. So you can see here I have the you can see that I have the interface gigs 0/0 configured for VPN 0, similar to this one here. And then I have the IP address mentioned here that I will be using. I will be using the same section on all these three interfaces so that they can communicate. Then this tunnel interface a little bit, finicky, but I will keep it like this for the time being. Sometimes it misbehaves in a lab environment. Maybe in the later on, maybe I have to disable this. But for now, let's keep it enabled and let's see. For this tunnel interface, basically used by the devices to send the traffic, send the data information. They will encapsulate by default in IPsec whenever they send the traffic out of these interfaces. Right? So we'll go through them later on. I will say what kind of encapsulations are used and why they use. All those things will be explained earlier and later on. Then you can see here what kind of services that are enabled on this interface, like DHCP services are enabled, DNS are enabled. Okay. Then ICMP is enabled so that we can ping each other and see. SSH is disabled by default. We can enable it later on. So all those things you can see here. HTTP is enabled here. And then we also have 512 that I configured for the management. The interface Ethernet 0 is used for this one. And then what is this? Sorry, Ethernet 0 is there, but this is the one that I have configured gig 0/1. And then it is using this IP address here, and I have not no shutdown that interface. Okay, so this is a basic bootstrap configuration. Later on, we can have more deep dive on in every topic. And okay, so this is the vManage. I'm not sure if I have any configuration here. No, so this I mean we have to bootstrap this same way. The only thing will different, the bootstrap configuration will be different only on the VPN section. The VPN 0 and VPN 512 configuration will change. So similarly for VPN 0, I will use Ethernet 0, and I will put an IP address from the same segment that I have used here. And for VPN 5112, I will use the same IP address segment that I have used here, so that they can have seamless connectivity among each other. Right? So I hope that you guys, have a little bit of understanding, like what we will be covering in this whole course, at least for the SD-WAN part. Similarly, we have the ACI as well. So similar topologies. I'm not similar topology. I mean, we have a similar lab for that one as well. Um, so any questions that you have regarding lab and regarding any admin related questions, that you can contact our my colleague as well here. He is on the call, Sajid. So he can take up your questions related to the course. Do you have any questions for me from a technical standpoint? I will stop my demo as a lecture today for now. So I will hand it over to him after this so that he can explain more on the course details. I hope you have at least got an understanding how I will be teaching and what will be my flow. If you guys have any comment on that one, or if you wanted to have any kind of few questions for me, then you can bring it up. Otherwise, I will, hand it over to Sajid.
Thank you, Arjun, for a detailed demo. The only thing was like I was concerned about the lab part. So I think we'll be starting. I just saw like we will be starting with vManage, how to configure it right from the
Yep, yep.
scratch.
Yes.
Yeah. So that's good. Yeah, looking forward.
No, I'm also looking forward to have you guys all on the team. So let's see.
Yep.
Okay, Sajid, you can take over. I
Yeah,
will stop sharing my screen.
yeah, I will take it from here. Thank you. Thanks for the session. Hello, everyone. Myself Sajid. I'm a student relationship manager and the counselor. So I'll be here to give you all the details regarding this course. Okay. So what all topics we are covering, what all modules will be there under this course, and what all access benefits you'll be getting along with this course. And as with this, I'll be providing you the pricing details, offering pricing, so which all are going on. Okay. So let me start with my first slide. So I hope you guys can see my screen. Yeah. So basically this course is like I have mentioned the course syllabus and class schedule here under this template. Okay. So here, as you can see, this is the SDN orchestration course. We are covering under this like Cisco SD-WAN, Cisco ACI, and Cisco ISE. Okay. So these three major courses we are covering under this combo course. Okay. And Here, this will be your class schedule. So this will be going to be a weekend batch, Saturday and Sunday from 7 p.m. to 9 p.m. IST, India time. Okay. So this will be 2 hours of session on particularly Saturday 2 hours, Sunday 2 hours. Okay. And the overall course duration will comes up for 4 to 4.5 months in case of any festivals, holidays. So it might get extended for next 2 weeks or 3 weeks maximum.
So any tentative date like we are targeting?
Yeah, let me give that as well. Thanks for your question. That I will be coming next on this point.
Okay,
Okay.
all right.
Yeah. Yeah, these will be covered under this, and these are your timings for the class. Okay, and let me move towards my next slide, which I have prepared here. So as you can see here, I have mentioned the course details like course enrollment access details. Once upon your enrollment, what all access you'll be getting. So I have mentioned those all points here. So you'll be getting the lifetime recording access of your classes, which you'll be attending to the Zoom meeting. So those recordings will be recorded on the cloud and it will be uploaded to our LMS. You'll be getting the LMS access. In there, you'll be getting your class recordings. So once we are done with our class, so the recordings are uploaded to the web portal in meantime of 1 to 1.5 hours. So using the cloud, it will get uploaded there. And later on, after 1 to 1.5 hour, whenever you want, you can go through the recordings. And that will remain for lifetime accessible. The web portal access will be for lifetime accessible. Okay, if you missed out any class as well due to any particular reason, so like let's say today we have completed the lecture, so later on you can go through the recordings and in your tomorrow's class you can clear your doubts with the trainer. So as per that you can have the same flow with your other students and the trainer. Okay, and secondly, we'll be providing you the remote lab access, which are hosted on our servers and cloud servers. So using that dedicated pods, so you'll be having your separate each and every person separate dedicated pods that you can access it totally remotely 24 into 7 unlimited. Whenever you want, you can access it as per your comfortable time, and you'll be getting the access and every details. Okay, so how you can access it using VPNs, using RDP, using remote IP, so every steps will be given to you. Okay, and here you'll be getting 3 months of remote lab access for dedicated modules, like let's say for Cisco SD-WAN 3 months of separate lab access, Cisco ISE separate lab access, and Cisco ACI you'll be getting the separate lab access. Okay, overall for all three modules, dedicated 3 months, 24 into 7, unlimited lab access you'll be getting. Okay, and we'll be providing you the dedicated materials like workbooks, PPTs, PDFs, step-by-step lab manuals, all the reading materials. So everything will be providing you that you can download and you can keep it with you as well. And the G Drive access remains with you for lifetime. If in case if you missed out any material, you can re-download it once again. Okay, and here we'll be assisting you for the home lab setup as well. Let's say if you have the good configuration of your system, then we'll be helping you to set up a home lab, so that once you are done with your remote lab access, you can practice on your personal laptop or it may be on your personal server. So we'll be helping you to set up a home lab. So here I have mentioned the home lab option. So from the G Drive, you need to download the OVA file and the related file for the home lab setup. So once you download it, so you can just let us know via our support deal. So one of our team member will connect with you, and he or she will be doing the setup on your system. Okay, and that will also remains with you for lifetime accessible. Till then, you keep on your machine, so you can access your labs. Okay, and next, we'll be providing you the 24 into 7 backend support from our team. Like if you are facing any issues, any queries regarding to the course or regarding to the portal or regarding to the labs, it may be related to you have doubt on the particular topic, you want to mention anything like this need to be covered, or you have any particular doubts, or it may be related to your production queries. So we are there to help you out. So you just need to raise a ticket on our support DL. One of our team member will connect with you and we will resolve your issues accordingly in meantime. Okay.